In this part of physics, we are going to talk about linear motion and angular motion and the difference between them. Also, we're going to talk about Kepler's first, second, third law. And also we are going to talk about acceleration due to gravity. Okay, here for example now, if an object is moving from point A to point B, this is point A and this is point B, and the object is moving from point A to point B. This one we call it a straight motion or linear motion, straight line motion or linear motion. So as you see, this motion now, when there is movement, there is motion. That means there is velocity, there is a speed, there is also what? Acceleration related. And if the movement is in circles, if an object is moving in circles like this, the object was at point A and it moved and came back to this point or stopped here, as long as this motion is what? In circles, that means here we have angular motion. Angular motion, that means we have angular displacement, we have angular velocity, and we have angular what? Acceleration. Okay, here for example now, we have a displacement which is d. And here we have angular displacement. So what is the angular displacement? Angular displacement means radian. How many radians did you move? How? For example, now what is radian? First, I have to know what is radian, and it's just the main unit in talking about what? Angular motion. Okay, if I have an angle here, this angle, as you see, I have this angle. I have here, for example, if I draw it like this, okay, I have here an angle which is what? Theta. This angle now, if the length of the arc, this is its arc, if the length now of its arc equals this radius of the angle, you see, if these two are equal, so that means this angle now we call it radian. We call it what? Radian, 1 radian. So what does it mean 1 radian? It can be like this, it can be radian. Okay, what does it mean now radian? Radian is an angle that its arc, it's a central angle, that means its vertex is on the center, that its arc, which is here, this one, the length of its arc is equal to the radius of the angle, and the radius of the circle. So here now we call this we call this angle now, we call it 1 radian. Okay, if an object now moved from this place to this place now, for example now, two similar angles of these ones now, in this case the angular displacement, that means the length of the movement here, by using radians, we're going to say it moved, this object now moved 2 radians. Okay, then here 3 radians, 4 radians, 5 radians, 6 radians. Okay, that means now if the object moved from point A and came back to the same point, which is A, that means it makes 1 whole rotation or 1 round. Here it makes 2 pi r as length of the circumference by meters. But how many radians did it move? It will move around 6.28 radians. That means, what does it mean 6.28 radians? That means it will be 6 angles like this. 6 angles like this, 0.28 of this angle now to make 1 whole rotation. So that means now angular displacement, it means how many radians, how many angles in radian did you move, okay? So that means it is what? Radian. So that means now the unit of angular displacement is radian, while the linear displacement is what? Meter. Okay, now we go to, this is now the first point. Second point now, we are talking about the velocity, which is linear velocity, and we are talking about here what? About angular velocity. Angular velocity is like this, W here, here. It equals what? How many radians? Look, that means if you move now 2 radians, If I have a circle like this and I have circular motion and I move to here 2 radians, to here 1 radian and here 2 radian. That means I move 2 radians. How much time did I take to move this radians now? These 2 radians, how much time? And this is called what? Angular velocity. So angular velocity, it means how many radians did you move per second? Per 1 second. How many radians did you move? But here, linear velocity, it means how many meters did you move in 1 second? How many radians did you move in 1 second? Okay, if I come to the third point now, which is linear velocity, linear acceleration. Linear acceleration means the change in velocity, this change in linear velocity divided by time. And it's going to be meter per second what squared. So that means the change in velocity, the change in linear velocity divided by what? By the time it took. Here now, the angular acceleration. Angular acceleration here, it means the change in angular velocity divided by time. So it's going to be radian per second here, which is velocity over the time again. So that means it's going to be what? Radian per second squared. So 1 radian means an angle that its arc is the same like its radius. That means now, instead of saying this angle in general, that this angle will equals 57.3 degrees. 37.3. That means it's less than 60 degrees. So that means how many angles of these ones now we have in 360? So when I move here, all movement from here till I come back to my origin, this one is 360 degrees. 360 degrees, and these ones 360 degrees. How many of these ones now? How many radius? It's going to be, if you divide 360 now divided by 57.3, you're going to get 6.28, around 6.28 what? Radians. So that means 6.28 angles like this in the whole round. Okay, from here to here, when I say from here to here is 1 pi. What does it mean 1 pi? Like this pi. Pi it equals 3.14. 3.14 what? 3.14 radian. What does it mean 3.14 radian now? 3.14 radian. It means 3 angles like this, 3 of them, 0.14 of them. When you multiply these ones now, 3.14 times this angle now, you will get 180. So 1 pi, it means 3.14 radian. But it means what angles exactly in degrees? It means 180. So that means 3.14 radian. It means 3.14 times that angle, which is 1 radian. It gives you what? 180. Okay, now we understand what the radian mean, and we understand what is the unit of angular displacement. It is radians, and we understand how many radians can be here in a whole rotation. Now, we need to move to the second point now, which is how can we convert? For example, now the car. The car, when it moves, as you see, it has tires, and these tires are in linear motion or in angular motion. They are in angular motion, right? They are in angular motion because they move in circles, right? They rotate these tires. But now the speed meter in front of the driver, when it gives you the speed, it gives you the speed in linear motion because it tells you how many kilometers do you move per 1 hour. So it gives you, it changed. So that means we convert the angular displacement, the angular velocity of the cars, of the tires, into what? Into straight line, which into linear motion, which is kilometers per hour. How do we convert? Okay, here now, if you want to find the distance, in meter, you multiply the angular displacement times the radius of the circle. So in the tires of the car, for the tires of the car, we multiply the theta, which is the radians, or the radians now, multiply how many radians times what? Times the radius of the tire. Okay, if we want to get the linear velocity, we multiply the angular velocity also times the radius. And if we want to get this one now, which is angular acceleration, we multiply, if we want to get linear acceleration, multiply angular acceleration by what? By the radius. That means now we understand how to, what does it mean? We understand the linear motion, three things, and angular motion, three things, and you understand how to convert between them from here to here. So that means angular motion, if you multiply it by the radius of the circle, or that means it's going to be changed into what? Into linear motion. I'm going to give you one easier thing. So when I tell you now, if if it makes three rotations per second, 3 rotations per second, that means how many, or what is the angular velocity if it makes 3 rotations per second? These 3 rotations now, you're going to multiply 3 times 1 rotation, which is 2 pi. It's going to be 6 pi over second. 6 pi, which is the pi 3.14, you're going to multiply by 3, then you get how many radians per second? How many radians per second? So this one now, again, this one now is 3 rotations per second. These 3 rotations per second, if something is rotate 3 rotations per second, how can I find that angular velocity? These 3 rotations, I multiply them by 2 pi, which is the 2 pi means 1 rotation. So I get now how many radians per second. If I want to change it now, this one now into linear velocity, these 3 rotations, I'm going to multiply them by 2 pi r, by 2 pi times the radius to change it into how many meters did that object move per second. We'll have examples then to solve what. So you understand now angular motion and also what? Linear motion. Related to the second part now, which is Kepler's laws. Kepler's first law, it says that orbits of the planets around the sun are elliptical. It's not circles, it's elliptical. The second law, it says that the planets, when they move around the sun, they sweep equal areas in equal time. Third one, it says that the time that it takes, the period it takes is squared for the planet to rotate around the sun. If you make it, the time is squared, or the period is squared of that planet, it takes, that means the time it takes to make one whole rotation. That time squared equals to the radius of the movement, what? Cubed. Okay, third point is, for example, now we have our Earth here, and there is an object here. This object, it will be attracted towards the Earth. This attraction now is by the gravity that is 9.28, right? Okay, this mass of the Earth, if this mass now is doubled, then it becomes twice. What will happen for this one now? What will happen for the gravity? Will it be twice? What will happen? Of course, the acceleration due to gravity will be also what? Doubled. Why? Because now these ones now, this is now an object, and this is now an object. So you have two objects, and between them there is an attraction. There is a attraction between these two objects. This attraction is given by this one, by this formula, which is equals mass 1 times mass of the second one, which is Earth, over the radius between them, what? Is squared. So what's the relationship between here now? The mass and the force, and the force is going to be mass times what? Mass times acceleration. So this mass will go by this mass, and here the acceleration due to gravity is going to be equals what? It's going to be directly proportional to the mass of Earth. So if this one is doubled, so the acceleration due to gravity will be also what? Doubled. Okay. What is the formula, for example, now, if I have the Earth here, if an object is here, it's going to be 9.8, the acceleration to the gravity here. But if it goes far away from the Earth, what will happen for 9.8? 9.8 will be what? will get less, while the mass of this object will remain as it is. The mass will remain as it is, but its weight will become less because you multiply by the gravity, and the gravity here, when it go far away of the Earth, it gonna decrease. How can we get then the gravity at this point? How can we get what? The gravity, the acceleration due to gravity at this point. We find that the acceleration here at this point, it equals the gravity of Earth at the normal place here. Then we multiply it by the radius of Earth. Radius of Earth, that means from here to here. This is the radius of what? Of Earth. Dividing by the radius of rotation. This object here, it will rotate here. This object will rotate here. What is now the radius of rotation here? So radius of rotation, then you make it what? Squared. So this formula now to find the acceleration due to gravity at any height above the Earth surface.